Welcome back everyone, this is CodePulse here with the fourth and final episode on how to create your own simple math interpreter in Python. So our interpreter is working perfectly, and so in this episode we are going to be adding unit testing to the interpreter. So if you're not sure what unit testing is, it is a way to test your code with more code. So we can manually come in here and test to make sure parentheses are working, for example. And so if we write this out, 2 multiplied by 1 plus 3, in our head we can figure out that the answer should be 8. So when we hit enter, we get a result of 8, so we know everything's working. But what we can do instead is write code which will test a wide variety of inputs and assert that the outputs are correct. So this is very useful if you add a new feature, for example, and then you can just run your tests and make sure that everything you've added in the past is still working and you haven't accidentally broken something. So we'll be writing unit tests for each step in our interpretation process, so for the lexer, the parser and the interpreter. Each step takes in certain input and produces certain output, so for the lexer, for example, we're taking in text and our output is a list of tokens. So we'll start with testing the lexer, and we're going to be using the built-in Python package called unit test to do this. So we'll create a new file to hold these tests. And the common naming convention is just to put in the name of what we're testing, followed by test. So we can begin by importing the unit test package, and in order to test the token outputs we're going to have to import our token class and our token type enum. And of course we are testing our lexer here, so we'll import that as well. So the way we do the unit testing in Python is we create a class, so I'll just call this test lexer because that's what we're doing. And this has to inherit the unit test case class. So a test case is just an individual unit we are testing, so in this case it's the lexer. What we can do now is write a function for each part of the lexer we want to test, and the unit test library will run them all for us. And it will tell us exactly which tests have passed and which ones haven't, if any have failed. So the first test we'll add is for testing an empty string, so I'll define a function called testEmpty. So we'll create a new lexer and we'll pass in an empty string. So this is of course when a user doesn't type in anything. We'll call generate tokens on this to get our output, and we'll just go ahead and convert that to a list. And we can assign that to the tokens variable. So now we have to figure out what the output should be, so with an empty string it only makes sense that the list of tokens is empty. So what we can now do is use the assert equal function provided by the unit test package, and we can ensure that the tokens result is an empty list. So that's our first simple test for the lexer out of the way. We also know that the lexer is supposed to ignore any white space, so no matter how much white space we put in, the result should be the same. So with that logic, if we duplicate this function and put in a bunch of random white space in here, because the white space should all be ignored, the output should still be an empty list. And just to remind you that a \t is equivalent to a tab character, and a \n is equivalent to a new line character. We'll now test how the lexer processes numbers. So we'll once again generate our lexer tokens, and this time we are going to test a bunch of numbers. So we could have 123, 123.456, and a few odd ones, 123 dot, dot 456, and just dot on its own. So you can see this test requires the fact that the whitespace test has already passed because we are using whitespace in here to separate our tokens. So we'll now make sure the tokens is equal to the correct list again, and now we need to put in here what we expect the lexer to return. So if we look at our input, we expect the first token to be a number token with the value of 123, so we'll put in exactly that. We'll duplicate that line, and now we expect a number token with the value 123.456, so we'll now put that in instead. The next one is 123 dot, and in our math interpreter this is just equivalent to writing 123.0. So we can copy the first one again. 0.456 in our math interpreter basically means 0.456, so we'll duplicate the second one and just put in 0.456. And finally, and I don't know why I have it, but point in my language is just the same as saying 0.0. So I'll duplicate the last one here and just change this to be 0.0. And I'm just using 3 digits here and 3 decimal places so that they're all lined up. So that's it for testing the numbers, and now we'll move on to testing the different operators. So in our input this time we'll have the plus, minus, multiply and divide operators. And as you've noticed, none of this syntax is actually correct in this interpreter, but in the lexer this input is completely fine, and since we are only testing the lexer here first, then we are able to do this. And once we move on to testing the parser, then we will be testing the correct order of tokens. So this time we are expecting a plus, minus, multiply and divide token, so we'll add all those to our list. And that's it for the operators, and now we'll move on to the parentheses. So we'll put the left and right parentheses into our lexer. And this time we expect to get a left parentheses and a right parentheses token. And finally, and this is the thing I like to do in my tests, is to test all of the things in one function all at once. So we'll create a function called testAll, and this time we'll just test some random expression. I'm not going to bother reading it out. So firstly we expect to get a number token here with the value of 27. Next we have a plus operator, so I'm just going to copy that from up here. We then have a left parentheses, so I'll copy that from here. Then another number with the value of 43, so I'll just duplicate this one and change that to 43. Then we have a divide operator, so I'll copy that once again from up here. Another number with the value of 36. Then we have a minus token. Another number here with the value of 48. A multiply operator, which is a multiply token. And then finally another number with the value of 51. And my bad, I forgot to include the right parentheses token as well after the 48, so let's add that in as well. So now we can go ahead and run our lexer test. So we're going to use the Python command, and to run a unit test you need to use -m followed by unit test, and then followed by the name of the file we are testing. So we're testing the lexer test.py file. So we'll run that, and as you can see it has ran the 5 tests successfully, and those are our 5 different functions. So assuming we've tested enough different variations in our code, then we are pretty certain that our lexer is working fine. So we can now move on to testing the parser. So we'll create a new file which is parser_test.py. We'll once again import unit test. The input of the parser is tokens, so we'll import token and token type. And of course we have to import the parser itself, don't forget that underscore at the end. And finally for the outputs we need the different node types. So we'll create another class for testing the parser, and this will once again have to inherit unittest.testCase. And we'll once again be testing the empty input first. So in this case we are going to test an empty list of tokens, so I'll assign that to the tokens variable. We'll pass those tokens into a new parser, and we'll call the parse method to get our node result. So we can assign that to node. We'll once again use the assert equal method and make sure the node is a certain value. So in this empty case where we don't have any tokens, well of course there couldn't be any node being produced, so we are expecting the output here to be none. Now we can write a test for the numbers. So we'll actually just copy this code, and this time we'll add in a number token. So we'll just put in some random value at 51.2. So with the number token, it's just simply a number node that we're expecting to get with the value of 51.2. We can now go ahead and test our individual operations. So those will do the plus, minus, multiply and divide operations. So we'll once again duplicate the code up here. And for our first one we're going to test a plus operation. So that's going to be a number plus another number, so we'll create a number token. And we'll put any arbitrary value, and then we want to put in a plus token and then another arbitrary value. So with this input we should be getting an add node as a return value, and the first node being added is a number node with the value of 27, and the second one is a number node with the value of 14. So now we'll duplicate this and do the minus operation. So we'll change this to be a minus token, and this time we're expected to get a subtract node. Next we have the multiply operation, so we'll change this to a multiply token, and we're expecting to get a multiply node. And then finally we have the division operation, so the divide token and then the divide node. we'll once again move on to testing an entire full expression in one function. So we'll create a test full expression function. So for our tokens, we're just going to use the tokens here for the full expression in the lexer. So we'll just go ahead and copy that. And we'll copy our assertion code. So we'll just remove what we have so far. And the root of our tree should be the operator that is evaluated last. And so that should be our add operation here. So 27 needs to be evaluated first. And then this entire right hand side should be evaluated first. So we'll put in an add node. We expect the first node to be our 27 number node, and then we have this multiply operation which needs to be evaluated. So we'll put in a multiply node, and we have this other operation that needs to be evaluated first, and we also have a number. So I'll put in the number node first, so that's going to be 51, and above it we'll put in this other operation which needs to be evaluated. So looking here at the order of operations, it is the minus operator which is happening last. So here we should have a subtract node, and the subtract operation needs this divide operation to be evaluated first, and also needs this number node to be evaluated. So we'll put in the divide operation, which is a divide node with the numbers 43 and 36, and then we have the number 48. So that should be it for testing the parser. So we'll make sure that is working. So once again, python 3-m unit test. And then the name of our file is parser_test. So as you can see, our parser and our tests are once again working perfectly. So now we can finally move on to testing the interpreter. So we'll write a file, interpreter_test.py. Let's go ahead and import unit test. We need to import the nodes for our input. We need the interpreter, and then the number value for our output. So we'll create our interpreter test class. And this time our interpreter only gets run when there is a value to be interpreted. So if you remember in main here, if there is no tree, if there is no node, then we just continue and we don't actually run the interpretation process. So we don't need any empty test case here. So the first thing we can test are numbers. So we'll create an interpreter and we will visit a node, and that is going to be a number node. And we'll just put in 51.2 and we'll assign this result to value. And if we have a number node with the value of 51.2, then we should just get a number value back with the value of 51.2. We'll now once again test the individual operations. So we'll go ahead and duplicate this, and we'll start with testing an add node of the two numbers 27 and 14. So 27 and 14 is 41. So if our interpreter is working fine, then the result should be 41. Okay, so let's move on to testing a subtract operation. So we'll test a subtract node, and this time the result should be 13. So we'll go ahead and put that in. Next we have the multiply. So we'll change this to a multiply node, and the result should be 378. And finally we have the divide node. So the divide operation should give us the result of 1.9285714285711429, and there's probably hundreds of more digits, but the calculator isn't accurate enough, I'm afraid. So realistically we need to figure out how many decimal places are we going to be happy with our interpreter. So all we're going to worry about is if our value is correct to 5 decimal places. So that'll be 1.92857. And the assert equal function allows us to add 5 here at the end, which means only make sure it's correct to 5 decimal places. Oh, and sorry, we actually have to use the assert almost equal function. And I almost forgot, we also need to test the divide by 0 error. So we're going to use with self.assert raises exception. So what this will do is run any code we have in here, and it will make sure that that code raises an exception. So this time we're going to interpret a divide node, and we'll purposely divide some number by 0. Okay, so now we have the final test of the video, which is going to be our full expression. So we'll create a tree variable, and we'll use the same tree we had in our parser test. So we'll get our interpreter to visit this tree. So we'll input that long expression into our calculator, so that is 27 plus and then we have multiply by 51 is going to be a subtract node, subtracting 48, and then we'll be dividing 43 by 36. Okay. So as you can see, our result is minus 2360.08 to 2 decimal places. So we'll once again use the assert almost equal function and we'll get the result value. And we said minus 2360.08, and that's to 2 decimal places. So now we are finally finished with our testing. So we'll go ahead and test our interpreter. So we'll put in the interpreter test.py file. And as you can see, our interpreter is also producing the correct results. So altogether, this means our entire math interpreter, from our lexer to the parser to the interpreter, is for the most part, to the amount I have tested, working fine. You'll also notice that I haven't tested any of the illegal character or invalid syntax errors in the lexer and the parser, and this is because it is understood that we could be extending our interpreter in the future, and something that might be invalid syntax now might no longer be invalid syntax in the future. So we should be only testing the stuff that we care about, that we don't expect to change, and we do expect that we could have new syntax in the future, and so it doesn't make sense to test that possibility. So that is going to mark the end of this series, so thank you all very much for watching, and special thanks to Helsfer Hesvik for being the top supporter on Patreon. And I hope to start a new series on my channel soon, so if you have any suggestions, just leave them down in the comments below, and I will see you all next time.